for those answers. Okay, every time we cannot help you out because you are going to complete your masters. You have to search out your things on your own. Okay, so minor product is getting formed. Now next one, but how do we explain the formation of product B, which is major? Okay, again the same question is here. Why the product B is major product? Look again at the free radical that is produced. Notice anything special about it. We can draw a resonance form. Okay, so now as we have seen that this free radical is always in resonance form. Okay, so that one is shifting its position. This carbon-carbon double bond is shifting its position. Now here I have shown the resonance form, that one is changing. Free radical is changing its position. Free radical is changing from tertiary free radical. Here is tertiary. This one is tertiary free radical. Write down under this structure it is a tertiary free radical. Write down under this structure this is secondary free radical. Okay. So resonance form, very nicely you have to indicate resonance form of the allylic radical. Write down each and everything. Tertiary free radical. This is secondary free radical. Show with the resonance. Now we will go next one again. Now here. Okay. So again they have shown here now how the resonance things occurs. Okay. In previous slide we have seen free radical have generated, tertiary free radical generated. That one has shifted again. See, here is tertiary free radical. In that one, this carbon-carbon double bond is got shifted in here in between these two, and this free radical, secondary free radical is generated in situ, and that one is getting abstracted bromine as a radical form, and product B has formed. Okay, so how the carbon-carbon double bond has shifted from one position to another position, how do you got this type of product, which is major product? Okay, which bond has broke, which bond has broke, which bond has formed, which bond has broken, and which bond has formed, that one everything I have written here. Now the thing is, still the question is as it is, why the product B is the more stable product? Again still the question is here. What is the explanation I have given here? There are two carbon on this molecule which can potentially participate in radical reactions. Okay, so two carbon explain this tertiary free radical as well as this secondary free radical. These two radicals, these two carbon atoms, they can potentially participate in the radical reaction. Okay, therefore can draw a reaction mechanism which shows Br2 reacting at this bottom tertiary carbon atom. Okay, now how the tertiary radical forms a new pi bond while the other pi bond breaks. This leaves one of the electrons on the top of alkene to form new bond with bromine, gives us a new Cr bond. If you analyze the bond that form and break in this section always, okay, note that this reaction has an extra pair of events. This is important, extra pair of events. One carbon-carbon pi bond breaks and another carbon-carbon pi bond forms. This net effect is looks like pi bond has moved, and this phenomenon is nothing but the allylic rearrangement. Okay, so how the carbon-carbon double bond, they do shift their position, and what is the effect of that, this rearrangement, that is allylic rearrangement, and how we do get these rearrangements, how do we get more stable product? But still question is unanswered, why the product B is more stable. Again still we have the same question. Okay, next one, the think. Now you know that one. We have different kinds of rules, Markovnikov, anti-Markovnikov, that one we know in case of addition to carbon-carbon double bond, and what type of products you are getting, whether that one is more substituted product, more substituted olefin we have to form, or less substituted olefin we have to form. Okay, so this is nothing but the Zetsev's rule of formation of the highly substituted olefin. Okay, so the answer of this one, why the product B is predominantly forming, because we have to follow the Zetsev's rule. Zetsev's rule, what it defines? It defines that more substituted alkene, that one is the most stable. Okay, so we have to pay attention, as we did get here tertiary free radical, resonating free radical, resonance form of this, as this one is giving us highly stable tertiary free radical. Okay, so this once we do get tertiary free radical, then also that one is going under arrangement like allylic arrangement, and after allylic arrangement we can get the ZZ product B, which is in which the olefin is highly substituted. Here you can pay attention. In on this olefin only one hydrogen is attached, and on these olefin two hydrogens are attached. Okay, so the olefins on which less hydrogens are there, so that olefin is the more stable, and we have to give the same product. Okay, we have to write down that one is the major product. So product B is tri substituted product. Here you can see the product B is tri substituted. One is methyl group is present, another is part of your ring system, and on another carbon atom part of ring system, but again one bromine atom is attached, so this is also bulky atom. So that's why this product is more substituted compared to product A, and that's why this product B is the our major product which follows the Z-save rule. Okay, so this is the scene of our bromination reaction. So many things you have to remember. First one, your basic things, whatever you have completed from the 11th standard to be up to BSc third year. What are how the different olefin addition reactions, how which path are there, HBr, how HBr is adding to carbon carbon double bond, how Br2 is adding to carbon carbon double bond, how N-bromosuccinimide may be adding to carbon carbon double bond. Okay, all these things if you know how hydroboration occurs to carbon carbon double bond. Okay, everything whatever in your syllabus, there is some aim, there is some target. Okay, so if you are going step by step on next level, you have to remember. If you remember those things, then you can compare those things with your present thing. Okay, radical reaction. Okay, this radical reaction is like that. We cannot follow the same rule whatever we are doing, addition of HBr, Br2, these things. And if we want to if we want to avoid the addition reaction, then how to change the reagent. Br2 we cannot use. So to understand all these things, you need to know the our basic things. On the basis of these basic things, you can go for the next reactions or next these things. Okay, so we will stop over here. How many are present today? Okay, 37. See, 37 who are there, I don't know, but don't miss the lectures. If you are going to miss the lecture, that would be very problematic at last exam. Okay, so